so let's start over again. We've reviewed factors and multiples. What is a prime number?
It only likes one in itself.
It's a number that only likes one in itself. It has how many factors?
One. No, two.
Two factors. How many factor pairs?
One.
Good. All right. And a composite number is a number that likes?
More than one.
Very good. More than one
Factor or factor.
more than one factor pair or more than
two factors.
Good. All right. What is the top number called in a fraction?
Numerator.
What's the bottom number called?
Denominator.
What is the denominator? Tell us.
The total.
The total. All right. Now, when I have fractions that follow the golden rule, when I have fractions that name the same amount, what do I call those fractions?
Equivalent.
They are equivalent fractions. Now, we have been learning about simplest form. Anytime, except now that we're learning equivalent fractions, sometimes it will just ask you to give an equivalent fraction. But when we get to adding and subtracting fractions, you're always going to have to make sure that your answer is in simplest form. So when I put a fraction in simplest form, that means that that fraction, that numerator, and that denominator have what?
The same the lowest terms of the number. The lowest factor
Is what?
one equation.
Good. Teamwork. Good. All right. So through all of that, I know that a fraction is in simplest form when my numerator and denominator only have what number in common?
One.
They have that GCF of 1. Everybody say GCF?
GCF.
Greatest.
Common factor.
The biggest factor that they have alike is 1. That's how I know it's in simplest form. If it doesn't matter, like half, 1/2. We've talked about this. I could have any fraction to equal 1/2 as my answer. But if I say, boys and girls, when you add these fractions, you must put your answers in simplest form, that takes away, okay, now Miss Moore doesn't need a key for these or these. Now Miss Moore just needs a key for what? 1/2. And if it's not in simplest form, guess what? It's wrong. I'd have to mark it off. But this chapter we're practicing equivalent fractions. We're practicing simplest form, and then next chapter we'll move into adding and subtracting these. But for today's lesson, we're going to have to use a little bit of what we've learned. Today's lesson is on what? What does it say on page 304? Comparing fractions. So today we're comparing fractions. So look on this paper with me. Let me pull it up on the board so y'all can see. We're on page 304, right? All right, good deal. Now, on page 304, the reason why you have out a sheet of scratch paper, you do not have room to do these on here. To show your work the way that you need to. Now, anytime we go to the gray book that's under your desk, that's where these papers come from. The good old silver Burdette. Whenever we go to that, these are the easy ones. We're not starting out in the green book because the green book gets kind of tough, right? We're going to start out easy so we can get the easy ones down. So, let me see where my pictures went.
That's what y'all call it? The silver.
That's the name of it. Silver Burdette. Like your green books are my math books. This is our silver Burdette. So whenever we compare numbers, now we've talked about comparing numbers before. When I compare numbers in math, now in Miss Elkins' class, if you compare the characters or compare the setting, what are you telling me about it?
Comparing different. What are
How they're different, how they're
alike.
alike. In math, though, how we tell how numbers are alike or different, what do we use in math?
Unequal signs. Like simplify.
Very good.
Greater than and less than.
So whenever I compare fractions, I'm going to use my greater than, less than,
Equal to.
Now, there's some important vocabulary words on here. I want you to circle the sentence for like fractions and circle the sentence for unlike fractions. All right, Aubrey, read about like fractions for us.
Like fractions have the same denominator.
All right, Maddox, read about unlike fractions.
Unlike fractions have different denominators.
All right, so that seems pretty easy, right? If they have the same denominator, what are they called?
Like fractions.
If they have the same denominator, what are they called?
Like fractions.
Like fractions. It's kind of like the word alike. They're alike, but we leave off the A. If they have the same denominator, they're what kind of fractions, everybody? Like fractions. But if they don't have the same type of denominator, they are what?
Unlike fractions.
There's that prefix that you're learning about in Miss Elkins' class. That's important. Now, to compare fractions. Of course, what do you think the easiest way to compare them is if we're comparing like fractions or unlike?
Bigger than less than.
No, your choices are like or unlike.
Like.
Which one do you think is easier? Like. Which ones do you think is harder? Unlike. Yep, you're right.
Less of like and more of unlike.
Now, even though, so of course this book is going to show you the long way, but I'm going to show you the shortcut way. So on your paper, I want us to write neatly so we can see what we're doing. Let's put number 1. Let's put number 1 on our paper. Gage should have a name, number, and date on there. And on number 1, this is kind of how we're going to set up whenever we compare fractions. So number 1 says 3/4. Put our circle. And 1/4. 3/4 and 1/4, right? Now, first I need you to tell me, are these like fractions or are these unlike fractions?
They're like fractions.
Why are they like fractions?
They
have the same denominator. Good. Now, when I'm comparing like fractions, you don't have a lot of work to do. You should be happy whenever they're like fractions because that means it's going to be easy peasy. Now, whenever I have my little fraction tiles like this, right? Do you see it's 1/4? Do you see this is 1/4? When they're like fractions, when the denominator is the
same.
I just compare my numerators like normal. Which number is bigger? Is 3 bigger or is 1 bigger?
3.
Is 3 bigger or smaller than 1?
3's bigger.
3's bigger, so which one does it have to eat? 3. The 3.
Oh, it's just like that.
So, when the denominators are the same, you don't have to do any work. It's simply asking you which one has more, 3 of these or 1 of these? 3. Now, does that make sense?
Yes.
That's easy peasy.
Wait, what if they have the same?
We'll get to it. We'll get to it. All right. So I want you to skip a line or 2 and write number 2. Skip a line or 2. And I want you to write these 4/6 or 5/6. Or 4/6 and 5/6 is what we're comparing. Now look at these. First tell me, are these like or unlike?
Like.
They're like because
They both have the same
they both have the same denominator. Now when they have the same denominator, it's easy peasy.
Yes.
Look at the numerator and say which one's bigger, 4 or 5.
5.
So it eats the 5. Now the reason why like fractions are easy is they're coming from the same size piece. This pizza up here was cut into how many pieces?
4.
All my pieces are the same size. This pizza right here is cut into what?
6.
They're all the same size, or they would be if that was perfect, right? They're the same size pieces, so I can just compare how many I have. So if I have the same size pieces and I have 3 of these and one of these, I know that that's going to be bigger because there's more, right? They're the same size piece. So, now, you cannot use these to compare unlike fractions. Because can you draw them perfectly?
No.
Please don't draw them. If they give you a model, then great, but please don't draw them. All right, so let's look at the next one. I have 1/4, so make sure you're writing this down, and 1/8. Now, do I have like fractions?
No.
No. I have unlike fractions because why?
Because
My denominators are different. But is there something you notice about these fractions,
They're
Aubrey?
both of one.
The numerator is the same, but the denominator is different.
Very good. The numerators are the same. Now I have a trick for the numerators. I have a trick. But if you use this trick, you really got to pay attention. Because this means that I have one piece of my pizza that's sliced into fourths. This means I have one piece of my pizza that's sliced into eighths. Now, remember we had a saying whenever we were talking about our slices. Hang on. They are two different wholes, but I want you to think about this. When my numerators are the same, stay with me. Let me get out my pieces. Don't shout out. Just hang on. Let me find my 1/8. Don't say anything. Now, hands down. So I haven't asked anything. When my numerators are the same, you have to use the saying, the bigger the denominator, the smaller the piece. Do you remember? As my fraction tiles got bigger, what happened to my pieces?
They got smaller.
So, with this, it's kind of opposite of my like fractions. Look at, if my numerators are the same, look at the bottom. Which one of these is the largest number?
8.
Then it's the smallest piece. Because which slice of pizza would you want, or which slice of cake would you want? The 1/4 of the cake or the 1/8 of the cake? Which one of those is going to be bigger? 1/4, because my 1/4.
If you have a 1/8, it just
Does that make sense?
Yes, because that's
smaller.
My smaller number of pieces is bigger than a lot of pieces, right?
So
I'm saying I have one of these and I have one of these. Well, naturally, if this cake, if they're the same sizes, which I should have made it the same size. Let's see if I can do this. Duplicate. Paste. This is why I say don't draw your models, because they have to be perfect. All right, now, I have 1/4 right here. I have 1/8 right here. Well, if this cake is cut into only 4 pieces, and this cake is cut into 8 pieces, yeah, 8 is a bigger number, but I gotta put more pieces in there. It makes our pieces smaller. Yeah.
Still the same.
If I have to take, well,
It's the same. Less
it wouldn't be the same. It would be less cake in my 1/8 than I'm gonna have in my 1/4. So let's recap. When I have like fractions, when my denominators are the same, it's easy peasy, right? Which one's bigger? When my numerators are the same, it's the opposite. The bigger the denominator, the
smaller the piece.
everybody, the bigger the denominator, the
Smaller the piece.
Good. Yes, sir, Caden?
When you asked what do you see about it, I saw another thing. I saw that both of them were already, what are they called again?
In simplest form?
Yeah, in
Good.
simplest form.
They were what kind of fractions?
They were unit fractions.
Everybody, what fraction has a 1 on top?
Unit fractions.
Good, Caden. I like that you're spotting those because that's very, very important.
The cake thing, the more you have, it's smaller pieces, but more people can have them.
Whenever I heard you say that they're opposite, it reminded me of like how addition and subtraction opposite,
Like their inverse operations.
Yes, sir, Elliot?
inverse operation.
Kinda.
I get why it was 1/4 instead of 1/8 because the pieces are bigger,
Yes.
but 1/8 the pieces are smaller.
Very good. Yes, sir, Marley?
So they're the same whole, but the pieces have to be cut off into.
It's a different, yeah. It's so. Think of a pizza. A pizza's the best thing because cakes can come in all different sizes. But y'all know my pizza's gonna be round, right?
Yes.
So my pizza normally comes in 8 slices. Well, if I take my pizza that's normally in 8s, right, and then I cut my pizza into 20ths, that would be some really small pieces, right? But when we don't know about fractions, we think a big number is a big piece of fraction, not necessarily. Now, so I've taught you the 2 easy ways. The like fractions, it's easy peasy. The unlike fractions, but the same numerator, it's the bigger the denominator, the smaller the piece. And it doesn't matter if the numerator is a 1 or a 3 or a 10, as long as they're both the same. All right, now let's look at number 4 and see what happens when neither one of them are the same. Now, these are very easy. Some of you already have a good concept of fractions and you know how to do this. But I'm going to warn you, whenever we get to IXL in the green book, they're not going to be easy like this. So you've got to learn. Let's learn with the easy ones, right?
Don't have a fixed mindset.
That's right. Learn with the easy ones. Now, look at these fractions. Are the denominators the same?
No.
Are the numerators the same?
No.
So I don't have any tricks I can use with this one, but that's fine. This is what you do. First step, all the time. Whoops, it's a little big. Draw your fraction bars and your circle right below it. Give yourself some room to write. This is what I'm going to set up to work this out.
There's a unit fraction.
Good. There is a unit fraction. All right, now, I don't have the same numerators. I don't have the same denominators, so I've got to work this one out. I'm setting it up to work it out. So I want to make this easy peasy. I want these to be like fractions. All right? What have we learned in math class about fractions? What have we learned that I can follow to make both of these into like fractions?
Golden rule.
The golden rule. And what are we following? What are we making whenever we follow the golden rule? What kind of fractions?
Unit.
Equivalent fractions. Equivalent fractions. All right, so look at your denominators. Whatever my denominators, boys and girls.
6 and 2.
6 and 2. Everybody, what's my denominators?
6 and 2.
Now, I want you to think of a multiple. Multiples are like what?
Skip counting.
Skip counting.
Or the answer.
Of a multiple that 6 and 2 have in common. If you're skip counting by 6s, if you're skip counting by 2s, I want the one they have in common, and I really want to pick the first one they have in common. This is not the GCF. Those are factors. This is if we're what? Multiples if we are
Skip counting.
skip counting. So if I'm skip counting by 6s, I'm going to say 6, 12, 18, and keep on. If I'm skip counting by 2s, I'm going to say 2, 4, 6, and keep on. What is the very first one that both of these have? 6. So, now let me tell you a secret. It's not like simplest form. You could pick any of those multiples, and it's going to work. It's just the smaller the number that I pick, the easier it is for me, right? So, what I'm going to do is I'm going to change both my denominators to 6. But now this is math. I can't just magically change them and not follow any rules, right? I got to follow some rules. So, we want to keep them lined up, and I want to say, okay, how did my 6 get to stay a 6? What did I multiply by?
1.
So, and you should be writing this with me. If I do times 1 on the bottom, what should I do on the top?
Times 1.
So that stays to 6 because my denominator was already a 6.
But you don't.
Now, over here, and I'm keeping these lined up. I'm not mixing it up, right? You with me? My 2 did not stay a 2. What did it turn into?
6.
So if my 2 turned into a 6, I had to say 2 times what?
3.
And I want you to write it. This is part of your problem solving. I want you to write it. You should be writing all of this with me. If you're not, you're getting behind. So if I do 2 times 3, what do I have to do to the top?
2 times 3. Or 1 times
1 times 3. What is 1 times 3?
3.
So my new numerator down here is a what?
3.
Now, do I have like fractions?
Yes.
Now, is it easy peasy?
Yes.
Yes, so now, which one should it eat? The 2 or the 3?
3.
And if you kept them lined up, that's your answer up top.
It's a lot of steps.
It's a lot of steps, but it'll get super easy. The biggest thing is remembering we're not doing simplest form on these. We're not finding factors. We're finding multiples, right? We're finding multiples, right? Yes, ma'am, Allison?
And number 4, you can kind of see our like the
Following the golden rule on the top and the bottom. Good. And that's why I want you to write it down so I can see how you're changing these. Yes, sir, Caden?
First thing, even when I saw the problem, can I tell you how I knew it was going to be 1, 2?
Well,
Or what?
no. Caden, tomorrow I'll need your explanation on tomorrow's lesson, okay? So remind me. All right, on number 5, I have 3/4 and 1/2. Do you have that written down?
Yes.
Write it down if you don't. Write it down. Everything you should be facing front. That shouldn't happen. Now, look at these. Are these like fractions? No. Why?
Because the numerator and the denominator aren't the same.
What makes a like fraction?
Denominator.
My denominators are not the same, so they're not like fractions. Stop. No, I'm not talking about the numerator right now. If I ask you what like fractions are, what are like fractions?
The denominators.
The denominators have to be the same. Are these denominators the same? No. Then you go and check the numerators. Are the numerators the same?
No.
So there's no easy peasy way around this, so we got to do some work. So draw your little, some people say it looks like a smiley face or
It
something.
looks like somebody yawning.
Yeah, draw your yawning face. Because we're about to set it up for, come on, Garrett. Y'all can't sit there, y'all. If you're sitting there, you're not getting what you need. Alright, so back on track. I'm going to take my denominators. What are my denominators, everybody?
4 and 2.
And I'm going to skip count, and I'm going to say, okay, what's the first one that they have in common?
4.
4. Because 2 would work here, but what's 4 times 1?
We're looking for multiples, not factors.
Well, yeah, and it would work here. It is a multiple here, but it's not a multiple here. It's a factor here, right? 4 times 1, so 4, 8, 12. Now, here's the thing, and it is 4. We want to pick 4. But let's say you messed up and you picked 8. Guess what? It's not a big deal. You're still going to get the same answer.
It's just going to be
This,
not as easy as if you picked
the smaller one. This is not comparing fractions, equivalent fractions. It's not like simplest form. Simplest form, we have 3 steps. 3 exact steps. What are those steps?
Find all factors.
Find all factors. And then divide. Simplest form, you have to do those 3 steps. Have to do those 3 steps. But this, you have a little bit of room. All you got to do is make them equivalent. Doesn't matter what numbers you use. All right, so what happened to my 4 that it got to stay a 4? 4 times
1.
So 3 times 1 is
3.
because I did it to the bottom, I got to do it to the top. Now, it's like I am separating my sides, right? There's that fraction. Now let's look over at this fraction. How did my 2 change into a 4?
Times 2.
Times 2 gave me 4. So if I do times 2 on the bottom, I have to do.
Times 2 on the top.
And 1 times 2 is
2.
Now listen, look at this 3/4. What did I multiply it by? Top and bottom. 1. Look at 1/2. What did I multiply it by? Times 2. They're going to be different. It's okay that they're different. You just got to remember on the numerator and denominator, you got to follow the what? Golden rule. All right, now down here, do I have like fractions? Yes. Now it's easy peasy. Which one's bigger?
3.
And look, whenever I eat this 3 right here, you got to bring it up because this is not my answer.
It's your
work.
That's just my work. That is just my work. It doesn't matter that you worked it out. You got to put your answer on the paper. Right? Do you see these 2 fractions on your paper, on your white paper, on this? No. But you should have these 2 fractions on your scratch paper, right?
Yes, ma'am.
Mm-hmm.
So when the numerator's the same, you just look at the denominator and see who's bigger?
Mm-hmm. All right, I want y'all to do number 6 on your own. Raise your hand once you get the answer. Do not talk. I'm going to give you a few seconds to do this one. Write down number 6. Do this one on your own. You can go make a new column if you need to. Make sure you're numbering these. All right, on number 6, I told you a few seconds. Why?
Because
It's my easy peasy. My denominators are the same. They are like fractions. Good. So I just say which number is bigger, 3 or 6?
6.
If I have 6/7, that's more than having 3/7, right? All right, good. Look at number 7. I'm going to give you a few seconds on this one, maybe a few seconds longer so you can think about it, but a few seconds on this one. Write this one down. Do it for me. So on this one, were these like fractions? No.
They're unlike
They're unlike, but you could use your trick for the.
And they were
They are
also
unit fractions.
They were also
Yes. They're unit fractions, yes.
unit fractions.
But I do see that my numerators are what?
Same.
So you can still use a trick. You don't have to work this out, but if you forget about the numerators trick, can you work this out? Yes. And it'll get you the same answer. But I'm trying to save you some time, save you some work. My numerators are the same. What should my sign be here? Greater than or less than?
Greater than.
Less than.
Yeah. Greater than.
Should be a greater than sign.
Because
Because when I look at, if my numerators are the same, look at your denominators and say the bigger the number, the
Smaller the piece.
So 4 is the biggest, but it's not the biggest piece. It is the smallest piece. The bigger the denominator, the smaller the piece. Make sure you corrected that.
Because 1/4 is just 1/4, but
All of this extra talking over each other doesn't help anything. It makes it more chaotic. All right, I want you to do number 8. All right, what sign should go here?
3.
What sign? Less than. And if you don't know what the sign is called, say the fraction. 2/5 is
Greater or less than.
less than 3/5. Because this was easy peasy. Why?
Because they're like
Denominators
fractions.
were the same. They're like fractions. Good. Now, on number 9, they are not. I have 1/2 and 2/5. So you got to come below number 9 and set up your little yawning face. It does kind of remind me of the golden snitch. I might call it the golden snitch because it's got the 2 little wings. It's something that we're not talking about in here. You got to read Harry Potter if you don't know what it is. All right. So what do you gotta do now?
You have to
Write
write your multiples.
Factors are for simplest form.
Write your multiples.
Think about your multiples of 2 and 5. So right now in your head, not out loud, skip count by 2s in your head. Then skip count by 5s in your head. And I want you to try and find the lowest one, but if we don't, it's okay. Presley, what'd you get?
10.
10, good. And 10 is the lowest one, but it doesn't matter which one. You could have picked 20. That's okay. I'll show you what happens with that in just a second. Now, this one is cool because both sides are going to have to change. My 2 changed to what?
10.
So 2 times
5.
1 times 5 is, all right, equivalent fraction there. How did this 5 change into a 10?
Times 2.
So 2 times 2 is 4. Now I have like fractions. Now it's easy peasy. Which one's bigger, 4 or 5?
5.
So if it eats the 5 down here, if I've kept them lined up, it should eat the 1/2 up there. Yes, sir, Gage?
You know what I just saw?
What?
I saw that they both are the same, like, multiplication. That's what's cool about it.
Yeah, it just kind of flipped it around, didn't it? Now, you don't have to write this down, but I want to show you. Do y'all have this?
Yes.
All right. I want to show you. Watch this. What would happen if I accidentally picked
20.
20? Really, any number, but we'll do it with 20.
You would still get
Hang on. Hang on. I'm showing you. I'm actually showing you. That means I need you to listen. How can 2 change to 20?
Times 10.
So 1 times 10 is, how did 5 change to 20? So 2 times 4 is, guess which one it's still going to eat? As long as you follow your golden rule, you're going to get the same answer every time. As long as you keep them lined up, you're still going to get the same answer. No matter what multiple you pick.
It just has to be on.
It just has to be a multiple.
And they have
It's
to
not
be
like
called in
simplest
one.
form.
Even if
Simplest
you flip
form,
them.
you have to follow 3 steps, right?
And
Equivalent fractions, no. As long as you follow the golden rule.
If you flip the 2 fractions around, like, switch the
I would.
sides,
Please
it would
don't.
still be.
It would, yes, but no. Please don't flip them. That's going to make things harder. Yes, ma'am. It would be, but the sign would flip too, so it's going to make it confusing.
Does it have to have both multiples?
Yes, it has to be a common multiple that they both have.
Yes.
All right, so last one, I want y'all to try this one on your own with working it out below it. And I've got to see where you're multiplying. I've got to see that golden rule.
Would it still be a like factor if they were both equal? Like the numerator with the same number and the denominator with the same number? Would it still be a like fraction?
If the denominator is the same. Just one little note. You gotta look at this key because if this says words only and you put numbers, it's wrong. So you should have marked it out. Alright, So let's look at this. What common multiple did you all use? 12. Did anybody use anything different than 12? All right, 12 is the smallest, so good job. Now, how did your 3 change into 12?
Times 4.
So if I do 3 times 4, I got to do
1 times 4.
which is 4. All right, how did this 4 change into 12?
3.
So 2 times 3 is,
6.
which one's bigger, 4 or 6?
6.
And if you wind them up, then it should match. All right.